here. And in this one, there's no calculus yet. This is 7x to the minus 7 minus x to the 1 over 7 power. Where that
Yeah.
1 over 7 comes from is here, which is the power. That's the index. If you're ever unsure how to remember that, this is x to the 1/2. There's really a 2 there and a 1 there. Now, do you feel like you could take a derivative of this?
Yeah,
Okay.
definitely.
Why don't you try that for me, please?
Okay. Okay. Y prime equals 7x 6 to the 6th power minus or plus 49x to the negative 8 power minus 1/7 x to the negative 6/7 power.
All right. Good job on that. Give me some feedback. Is that like a question you might see on a quiz or too easy, too hard?
For this chapter, I think it'd be too easy. I think that was like I'm on chapter 4 of the book, and that was like chapter 2. It was like our first
Okay.
lesson.
Okay. So that's where I maybe there's a disconnect. I mean, I saw things like power rule, product rule, uh, quotient, chain, so
Yeah.
like what a lot of students do is they'll actually send over what section they're working on so I can see like the problems there. Like I can replicate problems. I just need something to go off of. Like I don't want to waste your time by covering power rule if you got that down. Do you
Okay,
need
so
some product and quotient rule problems or chain rule problems to work on?
yeah, I think I'm pretty good on chain rule, so probably like product rule and quotient rule.
Okay. All right. So
Also,
let's start with a vanilla product rule problem. Um, so let's say it's we'll say y equals x to the 5th minus 9 squared times x cubed plus 1 to the power of 4. This is kind of a medium difficulty product rule potentially. It has some chain rule in it, so if you're unsure, let me know. Happy to help um,
okay.
guide you through it if you would like. Do you want to try it on your own, or do you want me to kind of work through it with you?
I think let me try it. I'm pretty sure
All right.
I would do this
And do
one.
not simplify because I'm not going to be able to simplify this.
Oh yeah, no, we
Just
don't simplify either.
yeah.
So okay, so I got the chain rule for the inside. So 5 comes out, and then so 5 times 2.
Let me write out the answer here just to
Oh
see
yeah.
if it so are and I'm just curious, are you breaking this apart into F and G or U and V?
No, I don't. I kind of just derivative
Just
the
do it as you
first
go. Okay.
times
So the
the
derivative
or
here is the first times the derivative of the second, or do you do the second? Well, how do you do it? Do you take the derivative of the first and times the second? What's your preference here?
derivative of the first
So
times
you're
the
gonna do
second.
the derivative of you're gonna do the derivative of the first. Okay. 2 times x to the 5th minus 9 times 5x to the 4th. Is that what you have?
Yes.
Okay, times the second plus keep the first. All right, now your derivative of the second is power rule followed by a chain rule, something like that.
Uh, for
If your order is
yes.
different, that's okay.
Yeah, that's exactly what I have. Yeah.
Fantastic. Okay, let me just look for a couple of more problems that are just a tiny bit more difficult than this. Then we'll move to quotient rule. These are super important to know because you will reuse them over and over in the course. Um, so you mentioned some trig stuff, so I think that's probably worth throwing at you next. Let's say it's something like e to the x plus sine x times natural log of x minus tangent x. Do you know all of your trig derivatives?
Yeah.
Okay. Now, one of the things I'm going to do here for you, because this becomes really helpful the more math class you take. In the chat here, I'm going to drop a reference sheet in. There's a bunch of these on the internet. This is just one that I like. You might consider printing this out as you're working through this course and having it available to you, or at least a screenshot of it up. So why don't you take the derivative of this? Let me know what you come up with.
Okay. Okay. I actually have a question. So whenever I'm doing the e to the x plus sine x, am I keeping those
Yes.
two together or do I separate them?
So the way you told me before, you like to take this one and take the derivative first. So the
Yeah.
derivative e to the x is itself, derivative sine is cosine x. They stay in parentheses.
Okay, so they stay together.
Yeah.
Okay.
Then you keep the second, and then you can tell me what you get from here.
Um, e to the x plus sine of x times 1 over x plus cosecant squared of x.
Tangent is secant squared.
Oh,
Tangent
oh,
goes with secant, and cotangent goes with cosecant.
yeah.
Okay. So that's product rule. I mean, product rule is really not a big deal. The quotient rule is, I guess, where it starts to get interesting. Um, so let's switch variables. Hopefully that's okay. You might see different variables in this. And you sound like typically I have to show this to students where you split the top and the bottom. If you don't have to do that, that's great. The order here does matter, though, as you probably know from the formula for quotient
Yeah.
rule. So go ahead and give this a try. Do not simplify. Let's just
Okay,
let me know when you got something. You can tell me what goes on the top.
so on the top I got 2z times z cubed minus 5 minus z squared plus 1 times 3z squared all over z cubed minus 5 squared.
Very good. Okay. The other types of problems. Let me see if I can find one here. I may have to go to. When you say you're in chapter 4, is that like applications of the derivative, like increasing, decreasing, min, max, inflection
No,
points?
not really.
So you're just doing pure derivatives still?
Yeah.
Okay. Are we getting close to some that you're seeing in class?
We've kind of done it where like we're applying it, but
Okay.
it's not like a question. He said like applying it's not gonna be on the test because we've talked about like this applying the trigonomic functions,
Mhm.
but I don't think like it's a big focus in our class.
Okay. So let me put something in front of you and ask you a question, just for kind of start to, is this quotient rule?
No,
Why not?
because the denominator doesn't have anything, I don't think.
It's not a function of x. So this would be best. This is actually power rule followed by chain rule. And that is one way to kind of study is to like not necessarily do them, but just talk your way through like, well, what is it? How about this one? Is this quotient rule?
I don't think so.
It's a maybe. Okay, the rewrite here is that you can do 6 times 3x squared minus pi to the power of -4. I would
Yeah.
do it using power rule, would never use quotient rule, but you could get away with doing it that way.
Yeah.
Okay. Um, this
So
is
like
good.
what? Because like kind of like the one you just put up, the 6 over. So like if it's 12 over x to the cubed, could I just move
Yes.
the x to the cubed to the numerator and use power rule?
Yes. Yes, of course.
Okay.
So do you have any type of review or anything from your book to send me? Because I'm still struggling. Like I can go as difficult as needed. I don't want to. I would really like to know a little bit more about what you're doing in class. The
So like
next.
some of the questions we have, it's honestly just like doing the problems of the quotient rule. So
Okay.
like 20 over sine squared x, 10 over x cubed minus 1 to the negative fifth power.
So kind of basic uh quotient rule questions.
Yeah.
Okay. So let me give you here's a classic test question. Um, prove the derivative of cotangent x is minus cosecant squared x. And the nice instructor will tell you using the quotient rule. A not very nice instructor will make you struggle. So that means you have to rewrite cotangent, and this is where your trig comes into play. You have to remember that cosine of x is cosine x over sine x. We know the answer. You have to get to the answer. So this time you have to use the quotient rule and simplify and get to the answer. Could you
Okay.
try that for me, please?
Yes. So after I do the quotient rule, I'm getting negative cosine, not cosecant.
Okay. So let's go bottom times the derivative of the top. Derivative of the top, what's the derivative of cosine?
Negative sine.
Negative sine x minus the top times the derivative of the bottom. Derivative of sine is cosine over the bottom squared. Did you get this far?
Yeah.
Okay, so the top becomes minus sine squared x minus cosine squared x. Is that clear how I got that?
Yes, and that's what I have too.
Okay. Now, there's a couple ways to do it. One is to use the Pythagorean identity in the numerator and
Equals.
recognize this is sine
Yeah.
squared x plus cosine squared x, and that this is 1, -1
Yeah.
on the top. That's way one. So this becomes -1 over sine squared x, which is negative cosecant squared x.
Okay.
That's way one. Way two, I'll do in a different color here in blue, is to divide each of these by sine squared x, which I don't like as much because then you end up having to use the more difficult. identity, you end up getting -1 minus cotangent squared x. And there is a identity for 1 plus cotangent squared x equals cosecant squared x. So if you
Yeah.
factor out a -1, you get 1 plus cotangent squared x, which is really cosecant squared x.
So why can't like the sine squared x on the numerator and denominator cancel out?
There's implied parentheses here.
Oh,
And
okay.
they're not written because they're ugly, but they are implied. I don't know why they're not written. I just say that they're ugly, but they're supposed to be there.
Okay.
I hate saying that word too. Like supposed to sounds bad as well because it's like, how do you know?
Yeah.
Um,
Okay. That makes sense.
so that's kind of your classic type of question. They could also give it to you for tangent, prove tangent is secant squared x. You can even get it for like secant x. So like secant x is really 1 over cosine x, and you could use that to prove the derivative of secant is secant x tangent x, and it's quotient rule again.
Yeah.
That's these are common test questions here that you might see. Let me put up a couple more. So do you just want kind of random problems? I mean, do you want me to focus in more on like we haven't done any much chain rule, but the product and quotient rule, trig functions, what kind of
Like what about
things?
derivatives of trig functions? Or like, because I've been struggling with like the like proving the equation or like finding the equation of tangent or like the not just tangent but like all the
Yeah, the
um
tangent line. Find it, finding the tangent line.
oh
That
well
that
yeah.
can be done. That can be done for any problem. Um, so do you have any problems you can send over? Anything at all to kind of start guiding us?
um what about like derivatives of trig functions like y equals 4 cosecant 10x over e to the 40th x.
Like this?
um the 4 cosecant is on the numerator with 10x.
Okay. Yeah. Is there any way you can send over some pictures of this or drop them in the chat, text, email,
Yeah,
whichever's
I can
preferred?
text you like pictures of the textbook.
That would be preferred. That'll help me figure out what kinds of questions you're looking at here. So this is a business phone. You can text your
Just on like regular phone.
right. This is my just letting you know you can text or
Oh,
call this
okay.
number. I use it for business though, so it's never a bother if you ever send something over
Okay.
for us to work on. I only look at it when I'm working, which is all the time, but right now. Okay, but you're saying that this is it for cosecant 10x over e to the 40x like this?
Yeah.
Okay, and this is just a straight derivative, or is it a tangent line problem?
It says differentiate and perform obvious simplification.
Uh, sure.
That's
So
it.
just a straight derivative.
Yeah.
Okay. So you've been doing really well at these. Like one thing I will suggest is occasionally it is good to write F and G for these. F is 4 cosecant 10x. G is e to the 40x. So your derivative of cosecant is cosecant cotangent with the right sign. What that ends up being negative when you do that.
Okay.
But you keep the inside function. So it's 4 cosecant 10x cotangent 10x, but then you multiply by the derivative of the inside function.
Okay.
So when that says obvious simplification, like -40 cosecant 10x cotangent 10x, seems like a reasonable thing. Okay, I
Yeah.
see you sent over some problems from your textbook. That'd be good.
I did. I just sent like the pages.
For G prime, what is the derivative of E? Well, it's always itself. And then you multiply
Yeah.
by the derivative of the inside function, which is which is 40. So the obvious simplification, if there is one, is just to put that in front. So sometimes that's better to do. So at least you know what you're putting in the top and the bottom. Could be helpful, could not be.
Yeah.
So you've got e to the 40x times the derivative of the top, which is the negative 40 cosecant 10x cotangent 10x minus the top 4 cosecant 10x times the derivative of the bottom, which is 40 e to the 40x over the bottom squared.
Yeah.
And then you go to the question, well, what is an obvious simplification? And I don't know. I mean, like obvious to one
Yeah.
person is different than another.
I feel like I
But
think that's good. I don't think I have to simplify for my teacher.
yeah, unless your teacher's really emphasizing that something there. So I did get those pictures. Let me quickly, yeah, I've got those up here. Um, yeah, so I see you picked like 18. That's a good one. Um, okay, let's look at 28.
Okay.
Another reason to send stuff over is I can sort of scan through and create an order for learning, if that helps. What
Yeah.
does this double apostrophe mean?
The second prime or the double prime.
Second derivative. So your first derivative right from um, is right from your reference sheet. Secant x, tangent x. Your second derivative is now product rule.
Oh, okay, yeah.
So could you try this one, please, for us?
Yeah. Mm, alright. Okay. I get secant x, tangent of x, times tangent of x, plus secant x times secant squared x.
Okay, so this one has, better obvious ones to maybe um, simplify, but that is correct. That's good. Now, do your quizzes typically represent your homework, or are they easier or harder or
They're usually easier. Like, there's not really like word problems or anything in there. It's very straightforward.
okay.
Yeah.
All right, so let's go to uh inverse trig functions. I know you mentioned that.
Yeah. And I sent
Okay, so
over for that
go ahead.
too. I sent over some problems for that too, or like the
Yeah,
text.
so these are there's if you look at that reference sheet I sent you, there's a couple more than this, but these are the basic ones. Okay. And they're they're kind of incomplete. Like the reality is that you're going to get a problem like this. Arc sine of u, okay, and u is going to be something more complicated. So its derivative of this ends up being 1 over the square root 1 minus u squared times u prime.
Yeah.
So the like that goes right in like the first problem you have here, number 13, which is arc sine inverse of 4x. Your u your u is 4x. Like the derivative of this is not, and this is the mistake most students make, it's not 1 minus x squared, it's 1 minus
4x
whatever
squared.
is in the place of that squared times the derivative of the inside function, which is 4.
Okay.
Did
I
you
didn't
see that,
realize that I
class?
had yeah, but I didn't realize that I had to multiply by the u prime. But
Yes.
that makes sense.
So what I'd like you to do is kind of based on, these are the kind of the most basic examples we can have here, and we'll increase the difficulty if we need to. 14 is using his inverse cosine, this is your u. This is your x, or your, if you, I like x, but if you prefer the u, your u is all this. So go
Okay.
ahead and take the derivative of this for us, please.
Okay, I get 1 over the square root 1 minus 10x squared times 10.
You're missing the negative there,
Ooh,
times
yeah.
10. And that's just a small thing that could trip you up. I think you should simplify like that. I would expect this, and I'm not really that uh I'm pretty I'm not super strict on stuff. I think that's reasonable to simplify, but
Yeah.
that's the that would be reasonable to me. So you have to know these rules. You've got them in your book. I'll have them up if you need, but the more difficult problems get to, and I'll just pick one here. I guess you didn't get, maybe tangent is somewhere else in your book, but a lot of students struggle with how to remember these. Do you get a reference sheet, or do you have to memorize them for the
I
test?
have to memorize them, but we're taught how to like derive them with like a little triangle. So like if I do forget, I can just
Well, I'll suggest an alternative. I'll suggest to memorize this one, and remember that sine and cosine are off by a negative.
yeah.
Tangent, memorize that one. That's an important one. Tangent and cotangent are off by a negative. And then memorize secant, and then secant and cosecant are off by a negative.
Yeah.
Plus this in here, but it's those are less commonly used. Um, they're not super common on the AP, but you may see them. Tan's the big one. Arctangent's one you're going to see like a lot. So if I give you a problem like this, like y equals the arctangent of the natural log of x, the derivative is 1 over 1 plus x squared, but that x is the inside function here. So that's the natural log of x squared. And then you have to multiply by the derivative of the inside function. What's the derivative of this?
1 over x.
1 over x. Something like
Wait,
that.
why am I leaving it L? Oh, because never mind. I get that.
Okay. Now there's also the possibility, and we'll just keep doing we'll keep doing it with arctangent. It could be something where the derivative of the inside function is more than just like itself. So that's where I really like changing this to arctangent of u, and u is e to the 2x, and writing out the derivative off to the side, just to kind of really emphasize like it's not just the inside function. So the derivative of arctangent is 1 over 1 plus u squared times u prime. The u is everything inside parentheses. The u prime is off to the side.
Yeah.
So this is e to the 2x squared times 2e to the 2x, like that. Something
Okay.
like that. Any questions up before I give you one to try?
I don't think so.
Okay, so let me give you one here. Uh, Arctangent's a big one. So let's say it's a natural log of x plus 1.
Okay. I get 1 over 1 plus natural log of x plus 1 squared times 1 over x plus 1.
Okay, good. Okay, so question for you, are these the same? Tan inverse x cubed, are these the same?
No.
Yeah, it was kind of deceptive. I didn't put the parentheses in the right place there. But no, these are not the same. This is more like the ones we've been doing. What would the derivative of this on the right look like? What would you do first?
Chain rule.
A power rule. You apply the power and then the chain rule. So
So
why don't you try the derivative of this for us?
okay.
And actually, I'm sorry. Yeah, go ahead and try this one. But that's fine.
Okay. I got 3 times 1 over 1 plus x squared times, that's it actually. Because derivative of x is just 1.
What about the outside? So the thing I was looking for first is the power rule. I didn't hear that. Maybe you did say it, but I didn't hear that.
I don't think I did do it.
Okay, and that's what's easy to do. It's easy to miss that. That it's you have to do that first, and then the chain rule part is the derivative of the inside function.
Okay. So don't I have to multiply by, oh wait, I don't have to multiply by 1, obviously.
You can. I mean, there's no derivative of this. I mean, it can
Yeah.
get extremely complex or not. That's why I'm like the ones you're showing me today aren't. They're on the lighter, easier side of the derivatives, but they can get harder quickly.
Yeah.
Okay, why don't you try 22 here? I'll snip that, and you'll need to grab the secant inverse formula up above, or I can grab it for you if you
The arc secant of x, yeah, that one. Okay.
so I put that up here. Let me go grab it. It's
Okay. I get 2 secant or arc secant x times 1 over absolute value of x square root of 1 minus x squared.
all right, good. So based on what I'm seeing, the real challenge would just be to memorize these plus remember like all the other rules.
Yeah.
So
So
question?
I was also given like the equation. Um, did I send you this? Hold on. It's like arc secant. No, not arc secant. Hold on. I'm gonna send you a picture of like a formula
Okay.
we were given.
And just to be clear, arcsecant and secant minus one, these are the same.
Yeah, it's not of that. I don't know why. It's not nothing with trig functions.
Okay.
Okay. Like the little gray box that I sent you.
Yeah, inverse, these are awful.
Yeah, like that formula.
Yeah. Um, okay. Yeah, we can do some inverse problems.
Okay.
Looking up some problems here, unless you have some.
That's the thing. There was no problems on that one. That's I think why I'm a little bit confused on it.
Right. Right. So here, we're gonna kind of do it. We'll do it a couple ways. So, all right. You might be asked to do it by hand, where you actually need to find the inverse function. Okay. So, do you remember how to find an inverse?
I do not actually.
So you switch x and y.
Yeah.
and then you solve for y.
Okay.
And so you end up getting y equals x minus 3 over negative 3. And if you want to make this pretty, which sometimes is preferred, you move that negative up, so it ends up being 3 minus x over 3, something like that.
X minus 3 over.
Now, this is the inverse function. What is the derivative of this?
Um, do I have, do I have to use quotient rule for that?
Nope. You should rewrite it slightly. Remember, when there's a constant on the
Oh,
bottom, you don't want to use the quotient rule.
so can I just multiply it all by 3? So like
Nope.
3 times
Like it's 3 over 3 minus x over 3. It's really 1 minus 1/3 x.
1/3.
So
Okay.
what is the derivative of that?
Um, negative 1/3.
Yes.
Okay.
All right. Now, if you look at oh, this isn't the best example. I don't want to do this. The the typical problem you'll get is not this though. This is just like a background thing, which is how to like find the inverse and then take its derivative. You
Yeah.
typically get a problem like this. So let me give you something that you might actually see on a test. So what is f of 1? What is f of 1? No calculus, just
Um,
evaluating the function.
1 minus 2. Oh,
No,
one.
like
What's one? Negative 1.
negative 1. Okay. So the way this would work is they would ask you to find f inverse of x prime like that, and that's where this would come in. So here we need this ordered pair, by the way. That'll come in handy. So here's the formula. This is the thing you're asking about. Sometimes they give you the ordered pair, sometimes you have to find it. So we need the inverse at at 1 or at negative 1. So it'll be written like this. So what is the derivative like this? Which is really 1 over f prime of f inverse of negative 1.
Yeah.
So f inverse of negative 1, that inside part, this is why it gets confusing because there's too many things to do. That inside part is the 1. So this really becomes the
Why is it
derivative
negative?
at 1. It's why is it negative 1?
But am I finding x?
So that's where this is we gotta back up. Okay, let me back up here. Do you agree that f of 1 is negative 1?
Yes.
What is f inverse of negative 1?
Uh, I don't know.
It's 1.
Okay.
So when your f of x goes this way, f inverse of x goes the other way.
Oh, okay. That makes sense.
So now when I put that formula up in front of you, the problem will ask you, it will say, find f inverse at negative 1 like that of x.
Yeah.
You got that. So this really is 1 over f prime of f inverse of negative 1. And f inverse of negative 1, that inside part is now
1.
1. So now you have to find the derivative of the original function and evaluate it at 1.
So wait,
So let me
can
grab
you
it.
do that?
So you have to take the derivative of this.
So 7x to the sixth plus 1.
And then you're evaluating at that one.
F prime 1 equals. So 7, 8.
The answer becomes 1/8.
Oh, that makes sense.
So here, like that's kind of the long way of doing it. What most students remember is that they have to one, take a derivative. Okay, so let me give you another problem here. And by the way, you can't find the inverse by hand on most of these, so you have to use this method. So first thing you have to do is take a derivative. What's the derivative of this one?
15x to the fourth plus 2.
Okay, good. And so that's the first thing. Then the students know that the inverse derivative is always like 1 over the derivative is what they typically remember. So it's 1 over this, but you have to know where to evaluate it. And where you evaluate it is based on the original function. So that's the second thing you need. That's usually the harder, is you need a point.
Okay.
So let's just say somewhere along the line, I say, okay, what is f of -1?
-1.
Could you evaluate this for us, please?
-3? Or is it
So I get
positive?
-3 minus 2 plus 5.
Yeah.
-1 to any to an even power. I'm sorry, -1 to an odd power is -1. -1 to an even power is 1.
Okay.
So this ends up being 0. So f of -1 equals 0.
Which
F
means
inverse of 0 equals -1.
yes.
So the question always is, well, which point do I evaluate it at? And that's where I like going back to this.
So then I plug in -1 to the derivative function, right?
Yes, exactly. So it's 1 over the 15x to the fourth plus 2, but
So 1 over 16.
you're evaluating at -1, which is, yeah.
Okay.
It's that easy, but it's that hard. I mean, it's
Yeah. That makes a lot more sense.
hard to explain. If you can explain that to someone else, you definitely understand it, but it's pretty tough.
Yeah. So I'm just finding the derivative and then find at the point and then plugging the point back into the derivative.
Yeah. And usually you're given something that you can't find the inverse of directly. So
Okay.
it's like you have to do it this way. Like there's no like workaround for it.
Yeah. And I
Okay,
think,
so lessons, by the way, are about 50 minutes. We're kind of coming up and closing out. So if it
yeah.
were me, some things to think about here is you need to memorize all your rules, like all of them. I know it sounds horrible.
The trig
I would,
ones, right?
yeah,
Okay.
trig inverse. You got to just know them all.
Okay.
Practice some. You got the odds in the back. Maybe look at those. There's a million calculators online if you're really stuck for that.
Yeah.
And then I guess last thing is try to redo some of the inverse problems that we did,
Yeah.
or look for some in your book. Try to follow the guided example
Okay.
there. All right, so I'm just going to pause just a tiny bit early. So let me go ahead and